So today we're going to talk about the last two logarithm laws, and they are product rule and quotient rule, or product law, quotient law. And product rule basically says that if I have a sum of two logarithms with the same base, so notice that we have log base b to the m plus log base b to the n, so those bases have to be the same. I can actually express this as a single logarithm with the same base, and I can multiply what's inside the logarithm, so m and n in this case. Okay, so as an example, log base 3 of 10 plus log base 3 of 4, I can actually express this as log base 3 of 10 times 4. So I would just express this as log base 3 of 40. Okay, and that will actually give me the same answer as the sum of these two logarithms with the same base. And this relates back to exponentials, because if we're multiplying two like bases, what do we do with the exponent on those like bases? Back from exponent laws from grade 9. If I multiply x to the a times x to the b, what must I do with a and b? Serena? We add them. So I can express the additions of two exponents, remember log is an exponent, as a multiple. And that's basically what's happening here. Multiples become additions. So it works both ways, right? So that's sort of where that rule comes from back from our exponent laws that we were talking about before. Okay, and then the second law is quotient law of logarithms. And basically it says that if I'm subtracting two logarithms and they must have the same base, then I can write them as a single logarithm with the insides divided. And I always do the first one. That will become the numerator here, and the second one will become the denominator here. So as an example here, if we took log base 2 of 100 minus log base 2 of 5, I can express this as log base 2 of 100 divided by 5, which is log base 2 of 20. And again, this sort of comes from that exponential law that if I am dividing two like bases, I keep the base and subtract the exponent. So subtractions become divisions. Divisions, when we're looking at exponent laws, become subtractions. So it's relating back to those exponent laws that we know. All right, so here is kind of a summary of the four laws. So we have laws which are power law, product law, we have quotient law, and this is kind of like the fourth log rule, which is change of base formula. And then we've practiced in our first lesson switching from logarithmic form into exponential form, and exponential form into logarithmic form. So these are your kind of like shortcuts for switching between the forms. And then other useful tips, we use this when we were evaluating logarithms, which is if I have two of the same, if I can create two of the same bases here, the answer is simply the exponent. The other thing that we know is that if I don't state a base, then the base is understood as 10. So that's one other thing that we learned. And log base b of b is 1. I don't think I've formally introduced this rule, but if I have any base, any logarithm to the base of itself, then that must be equal to 1. So what I mean by that is if I have log base 2 of 2, 2 raised to what exponent gives itself? 1. If I have log base 4 of 4, 4 raised to what exponent gives itself? 1. So if I have log base b of b, as long as those two things are the same, then that's going to equal 1. And that's also why this rule exists over here. Because if I were to take this b and bring it down in front, I would have b times log base a of a. And we know if I have log base a of a, anything to itself, then that must be 1. So that's why this rule is just equal to b. Okay, so just sort of explaining why this rule exists here. All right, so there's lots of different things that we need to know about logarithms. This is part of the reason why I said this unit can be a little bit challenging if you don't keep up with your stuff, because there's lots of new rules that are introduced, and we're going to use those rules in lots of different ways. So make sure you're keeping up with your homework. Make sure that you're coming to the next class ready with questions and all of that kind of stuff, okay? Matt, can you just pull your mask up, please? Thanks. All right, so here's the example. Let's write these as single logarithms. I have a bunch of logarithms that are all the same base. That's good, because I can't use these first two, or these rules 1 and 3, power law, or sorry, rules 2 and 3, product law and quotient law, unless I have logarithms that are the same base. So if I have, let's start with this. If I have the sum of two logarithms, sums become products. So I can express log base 4 of these two things by doing the product of 9 times 12. So sums become products. And subtractions of two logarithms with the same base become divisions. So I will have log base 4 of 9 times 12. You can simplify that, obviously, divided by 6. Okay, so if we want to, we can just simplify this as log base 4 of 18. 9 times 12 divided by 6. And that's all I'm asked to do, write as a single logarithm. So that's done. So if I were to go and calculate this, it should actually give me the exact same answer as just this single logarithm, log base 4 of 18. Okay, let's look at the second one here. So I'm actually just going to start with these three because these are all sums, and then we have a subtraction. Also, I'm noticing that these are all the same base. These all have base 10. They're all the common logarithm. So I can express all of these insides as a product inside here. So it'll be x times z times 4x minus log of z. And then I'm actually just going to simplify this quickly before we move to the next step. X squared times 4x, that's 4x cubed. And then we'll just have that z on the end there. So just applying some exponent rules to simplify here. Usually if I have a number, like a coefficient, I write that coefficient in front of all the variables. So that's why I moved that 4 to the front there. Okay, and then subtractions become divisions. So if I'm doing a subtraction of two things with the same base, I will have this first one on the top in the numerator, and then I can write that as a division of what's inside the second logarithm, z. And we can actually simplify this a little bit. Z and z will cancel, and I'm just going to be left with the log of 4 to the x cubed. And actually, this is kind of important. Can I bring this 3 down in front? Could I apply power law in a scenario like this? So the cubed, what does this apply to? Ian? Just the x. So I would want to be careful because there's a difference between log of 4x cubed and log of 4 times x cubed. In this case, I'm okay to bring this cube down. In the case that we have right now, I would not want to bring that cubed down in front. Okay, because only the x is cubed. It would need to be the whole thing inside the logarithm that's cubed. So just be mindful of that. All right, so continuing, our instructions are still write as a single logarithm. So one thing that's important to differentiate between is if I have the log of, let's say, 10 divided by 7, that is different than the log of 10 over the log of 7. Okay? This is what would result from having something like log of 10 minus log of 7. This is not equal to the log of 10 minus the log of 7. It's only that a division inside a logarithm becomes subtractions. The division of two logarithms, that's more like a change of base type formula. I can actually express this as log base 7 of 10, right? Change of base. And actually, it doesn't matter what the base is in here as long as the bases are the same. So we're actually going to utilize change of base formula here. Usually, we would have something like this, but it doesn't matter, right? Because technically, the bases here are both 10s. So we ignore the base, and this will actually be equal to the log base 6 of 8. Same thing as what we would do if we had the log of 8 over the log of 6. So this is change of base formula that we've been working with. Okay, you don't need to write this. I was just using that as an example. Same thing here. Okay, so we effectively kind of ignore these bases and just express the log of what's in the denominator as our new base, and it will be of whatever is in the numerator. So as long as those bases are the same, right? I couldn't do it if it was log base 4 of 8 over log base 3 of 6. They have to be the same. Before you apply things like product rule and quotient rule, you need to make sure any values that are in front of your logarithm get actually sort of like reverse power ruled up into the logarithm. So before I do subtractions become divisions, I'm actually going to take these multiples in front, and I'm going to do the opposite of what we've been doing with power law. I'm just going to do it in reverse. All of these rules work both ways, right? If I can bring the exponent down and write it as a multiple, then I can take multiples and bring them up and write them as exponents. So that's what we'll start with here. And I'm actually just going to simplify what's in here, just for our division and multiplication purposes. Okay, so let's start with these two. I'm just going to work my way left to right here. I have log of 15 minus log of 64. Those are going to become divisions. Subtractions become divisions. And then sums become multiples. So this is going to be multiplied. And we'll just simplify this a little bit here. 4 and 64 will just cancel into 16 and 1. So this will be the log base 10 common logarithm of 15 over 16. Okay, just dividing 64 by 4 to reduce those. Or if you want, you can do 15 times 4 divided by 64 and then reduce the fraction, whatever you want to do. Okay, so 3 laws at work here. First one is power law, where we bring the multiples up as exponents. Second one we did was quotient law, where we wrote the subtractions as divisions. And then product law, where we write the additions as multiples in here. Can I clarify anything so far? I know that there's a lot of rules that are at work here, so let me know if I can help with anything. It will take a little bit of practice to sort of get used to using all these rules and stuff like that. Okay, so why don't you guys try a couple of these out in example 2. We want to first write as a single logarithm, so use the laws. Most of them are going to be product law and quotient law here. Use the laws to write as a single logarithm and see if you can evaluate without using your calculator. Okay, I'll give you guys a couple seconds to try that. All right, I'm going to start putting up some solutions here as you guys are working. So sums become products. Subtractions become divisions. You can write that in a single logarithm. Okay, so first one, we're using product law. Sums become multiplications. So I kind of do what I do with exponents, right? I keep the base, and then I work with the insides of the logarithms. Just like when we do exponent laws, we keep the base and we work with the exponents. So I keep the base of the logarithm. The insides of the logarithms become products, so product rule. And then I'm just going to simplify. So I did 3 times 27, that's 81. And then I didn't have to use a calculator here. 9 to what exponent equals 81? That's just 2, right? So that's the answer to the logarithm. Okay, similarly, so this one's subtraction. So subtractions become divisions. That's quotient law. So I keep the base, keep log base 4, as long as there's both the same base here. And then we write 192 divided by the inside of the second logarithm, which is 3. That becomes 64. And again, no calculator needed here. 4 to what exponent equals 64? Must be 3, right? So that's the answer to the logarithm. Okay, last example, we needed to do what we did up here in part D. And we needed to sort of do the reverse of power law. So I looked at bringing each of these multiples up as exponents. So reverse power law, put the exponents up on your values here. I just calculated this, so 5 squared is 25. 16 to the exponent half, that's just the square root of 16. Half exponent is the same as a square root. So 16 to the half is 4. And then I have 2 logarithms with the same base being added. So sums become products inside the same logarithm. Log of 25 times 4. That's 100, and we know that the understood base here is 10. So 10 to what exponent equals 100? Would be 2. That's why the answer to this logarithm is 2. Okay, can I clarify any questions on these 3? Andreas. So all logarithms have a base. It's usually like a subscript here. So this is a base of 4. This is a base of 9. If you don't see a base written, then it's called the common logarithm, and it's understood that the base of that logarithm is 10. And what the logarithm is asking us, so for instance this right here, if the base is 4, This logarithm asks us 4 to what exponent equals 64. So that's why we need a base. That's part of the calculation of the logarithm. So that's why the answer to this logarithm is 3, right? Because 4 to the exponent 3 equals 64. So if you don't see a base, that little subscript, it's understood as a 10. Any other questions? By the way, especially where the ones where the base is 10, like part D and part C, where the logarithm base is 10, you can actually plug the original expression into your calculator and just check that it's the same as what you get out. That's an easy way to check your answer, especially for those bases of 10. I could check the answer to this as well. I just might need to use change of base formula to evaluate each of these logarithms individually, and then I would check it with that one as well. So you guys know how to evaluate something like this on your calculator, right? How do I do that? How do I evaluate log base 6 of 8? Emma? Log 8 divided by log 6. So we actually use the change of base formula for that. So if I wanted to evaluate like any of these, I would evaluate it like log, what is that, a 3? I would evaluate log 3 over log 9 plus log 27 over log 9. And then I would just double check that I would get 2 from that. Right? That's how I would evaluate all of these logarithms that don't have base 10 on my calculator. So I should actually be able to check every single answer that I'm getting for all of these, right, in my calculator using a log button. Some of you guys have this nice little log button on your calculator, and you can literally just plug in the expression into your calculator. I would still, of course, expect to see some of your work here. Like, you should be able to do something like this without necessarily needing to use a calculator or the log button on your calculator. But you can check by checking this. Okay, so write the logarithm as a sum or difference of logarithms. So now we're taking something that's already in a product or in a division, and we're actually expanding it into 2 logarithms. So if I have a product, products become what? This is product rule. So they're already multiplications. They become additions. Okay, so I can write this as log base 4 of A plus log base 4 of B. Products become sums. Sums can become products. Okay, this is product rule or product law. Okay, I have a couple options here. This one says write the logarithm as a sum or difference of logarithms. So could I create maybe 2 multiples that multiply to 40 and then split them? Or could I create something that divides into 40 and then split it? I could, right? So there's lots of different answers to this one. If I were to want to split this into logarithms, I could maybe write this as 4 times 10. And then I could split it into log base 4 plus log of 4 plus log of 10. Also, if I wanted to create a subtraction here, maybe I could have split log of 40 into the log of 80 over 2. And then maybe I can express this as the log of 80 minus the log of 2. Right? Lots of different answers to this one. I could have done 20 times 4. I could have done, whatever, 160 divided by 4. There's lots of different answers that we could have done to create a sum or a difference in logarithms. Okay, so many different answers to this one. So answers could vary to this one. Okay, next one. I have a multiplication of 3 logarithms. Okay, I did resume. Perfect. Okay, so any ideas what we should do for part C here? How can I express this as either a sum or difference of logarithms? Or which would I express it as if it's products inside the logarithm? Sarwa? Sums. So keep the logarithm with its base, and we're just going to express each of these as a sum of logarithms. So 3 sums because there's 3 products in here. If I wanted to maybe like fully expand this, I could maybe also apply power law and bring the 3 down in front of the logarithm. You don't have to, but if it says like express this in fully like expanded form or something like that, then you would bring the 3 down in front of that logarithm. So I guess we can just practice that now. Maybe we'll just take that and bring that down, so we know we can do that. Okay, any questions on any of these 3 here? All right, we're going to do a couple harder examples here, and then we'll have some time to practice. Okay, so simplify the following algebraic expressions. So simplified would be I gather as many logs as possible. If they have the same base, I put them into like a single logarithm. And then if it's already in a single logarithm, then we would do our best to simplify what's inside of that logarithm. Okay? So this one's already a single logarithm for part A here. Nothing that I really need to do as far as like using product rule or power rule or quotient rule or anything like that. But I would like to express this inside as a single x. We practiced some of this in grade 11 math because if I have 2 variables that are the same, then I would like to gather those variables together. So I'm going to express the square root. Remember, this is a 2 and a 1 here. I'm going to express that as a rational exponent, exponent of a half. And then I have 2 bases that are being divided that have exponents. So we're just thinking exponent rules here. How do I simplify something like x cubed divided by x to the half? What would I do with the exponents? Amelia? I do subtraction, so I'll do 3 minus a half. If you'd like, if you're not sure what that is as in fraction form, you can express this as 6 over 2 minus 1 over 2. And this will be log of x to the 5 over 2. No, keep in fraction form. Okay, and that's probably as simplified as we could get it. I guess if you want to, you could express this as a root. Could be x, the square root of x to the 5. Remember the square, that becomes like the root that's out here. So, I mean, either of these are acceptable for me. So whichever one you want to do. Okay, so really no logarithm rules needed here. We're just using exponent laws to simplify what's inside. All right. Logarithm rules for additions and subtractions. We are going to apply some of those, but first I think what we need to do is let's express any roots as just like exponents, rational exponents to start. So this will become 4 over 3, because that's a cube root, plus log to the x cubed, and then square roots become log to the x, or log of x to the half, because there's a 2 here and a 1 here. Okay, I'm just going to work my way left to right, so let's talk about these first. How do I express those 2 expressions, log base 4 of log base x to the exponent 4 over 3 and log base x cubed. I put that really far away for some reason. How do I express that sum as a single logarithm? Sums become what? Sarwa, want to take a guess?
I think you either multiply 4 over 3 by 3 or x squared by x squared.
Yes, so sums will become products. So I'll have x to the 4 over 3 times x to the 3. And then we'll subtract log base x of a half. Sorry, log base x to the half, I should say. Okay, and then subtractions become what? That? Divisions. So I'm going to have log of x to the 4 over 3 times log to the, times x to the cubed over x to the half. Okay, now that these are all in a single logarithm, our job is just to simplify inside here. Okay, so I want any base that's the same, which all of these bases are the same, x, x, and x. I want all of those to be expressed as a single x. So if I'm multiplying two bases, I keep the base and I'm going to add the exponents. I'll get x to the 4 over 3 plus 3. And then if I'm dividing this one, I will subtract the exponent. So we'll subtract the half from that. Okay, so just exponent rules here, just our classic grade 9 exponent rules. Okay, create a common denominator. I think we'll just create a denominator of 6 for all of these. You're welcome. Okay, so times 2 times 2, that's 8 over 6. Times 6 times 6, that's 18. Times 3 times 3, that's 3 over 6. And then just add those all together, or subtract. So 5 and 18 is 23 over 6. Okay, is this all in a single logarithm now? Yes? Is everything in what's inside the logarithm, is that all simplified now? Okay, perfect. The fraction is reduced as far as possible? Okay, perfect. We're done then. Okay, single logarithm and everything inside the logarithm is as simplified as possible. That's the goal when we simplify. If you wanted to, you could express this as log to the 6th root of 23. Again, either one is fine with me. If you want to express in rational form or in radical form, you choose whatever you want there. Okay. Last one. We have 2 logarithms with the same base. That's what we want in order to use log rules. So notice again, guys, that all of these logarithms, these were all base 10 logarithms here. They all have to have the same base in order for me to combine them in the same logarithm. Second one also, there's base 10 and base 10, so that's good. We'll continue with our log rules. Subtractions. I have a log of something, subtract a log of something. Subtractions become what? Divisions. So I'm going to express this in one logarithm, and it will be 3x minus 9 over what's inside the other logarithm, x squared minus 9. So I've now expressed this in a single logarithm. Keep the logarithm and then divide what you're subtracting inside the logarithms. Now I want to see if I can simplify this expression any further. So whenever we have things with x's, like binomials and things like this, we'll try to common factor. Okay, so we're getting into a couple little factoring things. I'm going to common factor a 3 from the top. Is there anything we can do with the denominator here to maybe simplify this or factor this? Clayton? Difference of squares on the bottom. X squared minus 9. That factors into x plus 3, x minus 3. Okay, anyone see what we can do? So we're thinking back to rational expressions in grade 11 here. Kenzie? These will cancel. Perfect. So now we have log of 3 over x plus 3. Should I reduce the 3's here? Why not? Because it has an addition. So if I try to reduce or cancel something that's right next to a plus or a minus, I can't do that, right? I can't individually cancel from individual terms. So no canceling and reducing here, okay? Because there's a plus in between here. Is this done then? Is this in a single logarithm? Yes, as much as possible. Have we simplified this interior part as much as possible? Yes, we're good. So that's our final. Can I clarify anything here? All right. So we have